Okay, we're going to be continuing our Unit 4 polynomial review. In the review packet, we're picking up with question number 10, which is just asking us to sketch some graphs without finding any zeros. We are not trying to be very detailed here. We just need to know the leading coefficient, the degree, the end behavior, and the maximum number of turns. So let's take a look at these functions and see if we can do that. We don't have to factor, we don't have to solve. All we have to know is the general shape of these functions. So let's go ahead and start with the degree and leading coefficient, because those are going to be helpful for us. For the degree, I'm going to look at my variable, x, and I'm going to find which term has the highest power of x, which in this case is here, x to the fifth. That degree of 5 tells me that my pattern should be low to high. Now the leading coefficient is an invisible 1, so a, my leading coefficient, equals an invisible 1. That's a positive number, so that means that I am right side up. So that means my pattern, low to high, will be true. So I'm going to go ahead and start with a low and end with a high. There are my arrows to tell me about my end behavior. All I need to know now is the maximum number of turns. So I'm going to go ahead and say max turns here. This is a fifth degree function. Remember, the max turns is one less than that degree, so I can have 4 turns maximum. So if I want to go ahead and show all 4 of those turns, just to be creative, I'm going to come up from here. Every hill and valley is a turn. So if I come up here, I can have a hill that's 1 turn, a valley that makes 2, a hill that makes 3, a valley that makes 4, and I need to end high, which is exactly what happens as long as I don't turn around too many times. That's one way to draw this graph. If you don't want to turn around that much, you don't have to, as long as you go from low to high and you don't turn around too much and you don't have a perfectly straight line. So I could also just turn around twice like that. Or if I want to go from low to high, as long as I do a little wiggle in the middle, I don't have to turn around at all. All of these would be acceptable for question 10a. For 10b, we have a slightly different equation. The highest power of x is 4, so my degree 4 tells me I should be high to high. But the leading coefficient, a, of -1, tells me that is upside down, which means my high to high will become low to low. So I'm going to start here and end here, low to low. Now this is a 4th degree function, which means the maximum turns, max turns, is 1 less, so it's 3. So if I start here, I can turn around once, twice, 3 times. They can look kind of like an M. I don't have to turn around 3 times. As long as I start low and end low, and I get from here to here, I can turn around just once. Now I do have to turn around at least once. If I need to get from low to low, I'm going to have to turn around so I can get back to the proper end behavior, but I don't have to turn around the maximum of times. It's just one option. So both graphs in green are acceptable as an answer for 10b. However high or low you go when you turn around is your creative license. So I just went a little bit shallow for these. All right, let's get to real graphing. Good stuff. We're going to go to question 11. This is going to use what we now know about degree, leading coefficient, and end behavior, and it's going to incorporate what we know about roots and y-intercepts to find the actual function using its multiplicity as well. So let's see what we can do for number 11a. The first thing I'd like to do is start with the zeros to figure out what points I can put on the map. So I'm going to find my x-intercepts by factoring and solving, and I'm going to find my y-intercept by plugging in 0. So for my x-intercepts, I'm going to go ahead and take this equation, f of x, blah, blah, blah. I'm going to set it equal to 0, and I'm going to factor by grouping, it looks like, because I have no GCF, and I've got 4 terms. So I'm going to group these 2 together and these 2 as well. So for my first group, my GCF is x squared, and when I factor it out, I get x plus 1 left over. For my second group, my GCF is negative 16, and when I factor it away, I get x. This negative 16 divided by negative 16 becomes positive 1, so I get x plus 1 for both. Now I'm going to bring that x plus 1 to the front, and the x squared and the negative 16 will go in their own factor, and here I can factor one more time. X squared minus 16 is a difference of squares, x being squared and 4 being squared. So I'm going to put x and 4 in parentheses, 1 plus, 1 minus, and now we are completely factored. I'll bring down the x plus 1 from in front just to make sure that I've got it. And from this factored form, I can find all of my solutions. I have to set it equal to 0, and we'll find our answers one at a time. If x plus 1 equals 0, then x is negative 1. So I'm going to graph negative 1 right there. If x plus 4 equals 0, x is negative 4. So I'll graph negative 4 right about there. Last up, we have x minus 4 equals 0, which tells me that I have an x value of positive 4, which we'll put here. Now those were all of my x-intercepts. To find my y-intercept, I'm going to look at my original equation, and I'm going to plug in 0 for x. That becomes 0 cubed, which disappears. 0 squared disappears. 16 times 0 disappears. The only number left when I plug in 0 is this negative 16 at the end. So my y-intercept, y equals negative 16. So I'm going to go ahead and I don't have to make it to scale. I'm going to go ahead and call it this number, negative 16. As long as I get it labeled, I'm happy. Now, if we look at my degree and my leading coefficient, for this function, my highest power of x is 3, x cubed in front. So with a degree of 3, I should be low to high. The leading coefficient is an invisible 1, which is positive. So that means I'm right side up. So I'm going to keep my low to high pattern. So I have to start low and end high. Let's figure out what happens there when I go to solve, or to draw my graph. So I have to start down here by this blue arrow somewhere. I have to get to negative 4. Oh, let's talk about multiplicities. Each of these solutions, x equals negative 1, that just happens once, multiplicity of 1. X equals negative 4, multiplicity of 1, and x equals 4, multiplicity of 1. If I have an odd multiplicity, when I get to that point on the graph, I'm going to cut. So I'll put a C. These are C's. It's terrible, really hard to see, but those are C's. So when I get to all 3 of those points on the graph when I'm drawing, I'm going to cut right through. So my first job is in blue. I'm going to start near this blue arrow down here. I have to get to the negative 4, and I have to cut through it. So I'll come up this way, and I'll cut through it. After I cut through negative 4, I have to get to the negative 1, and I'm going to cut through it again. And in order to get there, I must turn around somewhere in here. So I'm just going to turn around there and get to my negative 1 and cut through it. The next place I have to hit is my y-intercept, which I put all the way down here. I can put it wherever I want as long as I label it. So there's my negative 16. And then the last place I have to hit is this positive 4. And again, when I get there, I've got to cut straight through it. So I'm going to turn this guy around, cut through at the proper place, and end up high right where I have to. That's it for 11a. Let's go ahead and try something similar with 11b. Now 11b is already factored. If it's helpful for you, you can go ahead and rewrite this in its most expanded form, which doesn't use the exponents 2. It actually would have everything written side by side. So x plus 3 squared means x plus 3 times itself. And then we would have the x minus 1. And then we would have the x minus 4 times itself. X minus 4 times x minus 4. Now you don't have to do this step, but it is helpful to see what your solutions are, what their multiplicities are, and what your degree is going to be. First, let's find our solutions. I'm going to take each one of these and set it equal to 0. When I set x plus 3 equal to 0, I'm going to get x equals negative 3. And if you notice, because it's squared, we're going to get that number twice, so multiplicity of 2. So I'm going to put it right here on my graph, negative 3. And I'm going to go ahead and talk about its multiplicity. Since it's an even number, it's going to bounce. So I'm going to put a b on top of that point. Up next, I have x minus 1 equals 0. So x is going to be 1, and that number will only happen once in this problem. So when I get to 1 right here, 1, that's going to cut. So I'll use a c. Last up, x minus 4 equals 0, which tells me that x is positive 4, and it has a multiplicity again of 2. So when I get to positive 4, 4, it's going to bounce again. All right, now I'm going to need to find my y-intercept. So to find my y-intercept, I'm going to plug in 0. I can either plug it in up top or into this original equation. It doesn't matter as long as I plug in 0. So if I plug in x equals 0, I'm going to find my y value. That is my solution. So my y-intercept, I plug in 0. So if I plug in 0 to this first term, it'll become a positive 3. Times this term, another positive 3. Or if I use the one below, I just do 3 squared. Next, I will get a negative 1. Negative 1. Up next, I'll get 2 negative 4s in a row. So times negative 4 times negative 4, and I'm off the board, and that's negative. Okay. And last but not least, I have a negative in front, so this whole thing has to be negative. So 3 times 3 and negative 1 and 4 times 4, and if I multiply all of those together, I get 144. I have negative here and here. That gives me a positive. Another negative is negative, and this negative from the front is positive. So I get positive 144 when I multiply all those numbers together. I'm going to go ahead and not count that out and just put it right here because I feel like it. So there's 144 on my y-axis. Now let's take a look at our degree and leading coefficient. For my degree, this polynomial is not expanded. It hasn't been multiplied together. And I don't have to multiply the entire thing together, but what I do have to do is look at each factor, find its highest power of x, and multiply those back together. So for my degree, I'm going to look at the highest power here, which is x to the first, times 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 x to the first. So x times x times x times x is x to the fifth. My degree is 5. Now, the leading coefficient, each one of these x's has a leading coefficient of 1, but I do have that negative from the front. So my leading coefficient A is actually negative 1, which means that the D is 5, gives me a pattern and behavior of low to high. This is going to be upside down. So this, oh goodness, that's supposed to be the word upside down. Let's erase that. And let's just say it out loud. And let's say this is actually going to flip upside down. It's going to be high to low. So I'm going to start at pi, I'm going to end down low. And now I'm ready to go ahead and draw my graph. Let's start up high, and the first place I have to hit is this negative 3. Once I get there, I'm going to bounce off of it. So I'm coming from here, I'm going to get to the negative 3, and I'm going to bounce like this with a curve that looks like a parabola. The next place I want to go is the number 1, but I have to cross through the 144 on the y-axis first. So I'm going to come all the way up here and get through this number, turn around, and get to 1. And when I get to 1, I'm going to redo that so I don't overlap myself. Come up here, get to 144, come through here and cut. Once I cut through 1, my next job is to get to the number 4, and I have to bounce off of it. So I'm going to turn around to get to 4, bounce off of it, and it heads me in the correct direction to get to the proper end behavior. All right, that's it for my graphing. We're going to pick up with the next problem in the next video.